Hello and welcome to Basic Electricity 2 Troubleshooting Opens. The purpose of this lesson is to teach you the basic theory behind troubleshooting an open fault in an electric circuit. At the end of this lesson, you should be able to define an open, explain the process for finding an open, and find an open fault in a circuit. An open is an unintentional break in the path for current flow. The break that you see here is an example of an open. Now recall from Basic Electricity 1 that voltage is analogous to pressure in a fluid system. In this fluid system we have a pump for our flow source, a water wheel for our load, and 3 valves that will serve as control devices. Now notice that when the pump is turned on, we initially do not have flow through the water wheel because the 3 valves are shut. The blue line shows the discharge pressure of the pump being applied to the first valve, but nothing else. If we open the first valve, we see that the discharge pressure of the pump is applied to the second valve. Then if we open the second valve, we see that the discharge pressure of the pump is applied to the water wheel and to the third valve. However, notice that the water wheel still does not spin. This is because the flow necessary to spin the water wheel requires a completed path for current. It is only when we open the third valve that the water from the discharge of the pump can reach the suction of the pump and the water wheel can do work. Now electrical circuits work on the same principles. That is, the electrons must have a complete path for current if they're to do anything useful. In this electrical circuit we have a battery for our source, a lamp for our load, and 3 single-pole single-throw switches to serve as our control devices. Initially, the lamp is not energized because all 3 of the switches are open. That is, the electrons do not have a complete path for flow. The voltage from the battery is applied to the first switch, and that is all. Now, if we shut the first switch, we see that the voltage is applied to the second switch. When we shut the second switch, we see that the source voltage is applied to the lamp, but the lamp does not illuminate. Just as applying pressure to the water wheel would not make it spin, simply applying voltage to our load will not cause it to light. It's only when we close the third switch and complete the path for current flow that we see the lamp light. Now it is this principle of operation that will help us find an open in a circuit. Before we dive into the circuit though, let's take a look at a few rules for finding opens. First, opens do not blow fuses. Fuses blow because of a high current condition. If a circuit is open, however, the current through that circuit will be 0. So if your initial condition is a blown fuse, then you are looking for a short and not an open. Second, when troubleshooting an open, you should use a voltmeter or the voltmeter function on your multimeter. Understand, however, that this will require the circuit to be energized during testing, so be sure to take any necessary electrical safety precautions. Third, the open will be between your last point of potential and your point of no potential. Now what I mean by that is you will connect your negative lead to the neutral or common and work your way down the loop with your positive lead until you find a drop in potential. When you find this drop, you have found the open. So consider this simple circuit, which contains a 120 volts DC battery, a single fuse, 3 single-pole single-throw switches, and a lamp. During normal operation with the switches open, these are the voltages that you will see. Since the first switch is an intentional break in the circuit, the last point of potential is directly upstream of that switch. When we shut the first switch, we see that the last point of potential is now directly upstream of the second switch. With each successive switch, we move the last point of potential toward the load until all of the switches are closed. At that point, the last point of potential will be at the lamp itself. Since the lamp is the only significantly resistive component in the circuit, it will drop nearly all of the voltage and will light up. But what if you have all the switches closed but still have no light from the lamp? Based on what you know of the circuit, if the problem is an open, you should be able to predict the location of the problem based on the voltage readings. Let's take a look. Given the following voltage readings, where do you believe the fault lies? Now I'll pause the video at this point on each of my examples to give you an opportunity to guess. When you have the answer, just push play to continue. If you said the fault is in the wire between the second and third switch, then you are correct. The last point of potential is directly downstream of the second switch, so the open must be in the downstream wire. Now consider this one. Given these readings, where do you believe the fault lies? In this circuit, there's an open in the first control switch itself. Again, the open is between the last point of potential and the point of no potential. How about now? Though this may seem strange at first, this is probably the most common open fault, a simple blown bulb. This is important to know. Taken from the readings alone, a blown bulb looks just like a functioning circuit. The only difference is there's no light. Here's one more. Can you see where the open is? In this example, the open is in the neutral line between the bulb and the positive terminal on the battery. As we stated before, even though 120 volts is present on the lamp, it cannot energize without completing a path for current. Okay, to recap, we've defined an open, identified key troubleshooting points, and gone through a few practice problems. In our next lesson, we will discuss troubleshooting shorts and shunts. I hope you've enjoyed this video. If you have any questions, please leave them in the comment section below. Have a great day.